tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia, sebuah inisiatif e-didik Malaysia dan Kelab Guru Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Selamat petang dan salam sejahtera. Hai semua para guru, ibu bapa yang dihormati dan para pelajar yang cikgu kasihi sekalian. Selamat datang ke Pusat Tuition Academy YouTuber, usaha sama e-didik Malaysia dan Kelab Guru Malaysia. Bermula percuma, selamanya percuma. Untuk mendapatkan keberkatan kelas kita pada petang ini, mari kita sama-sama mulakan kelas dengan bacaan doa mengikut agama masing-masing. Apa khabar para pelajar yang cikgu kasihi sekalian? Harap semuanya berada dalam keadaan baik dan bersedia untuk meneruskan kelas kita pada petang ini. Cikgu percaya pelajar-pelajar dah tak sabar untuk mengikuti kelas kita kali ini. Cikgu perkenalkan diri dahulu. Nama cikgu Teacher Tan dari Kolej Matrikulasi Selangor selaku moderator pada petang ini. Hari ini kita ada kelas tuition kimia. Pada petang ini kita bersiaran langsung dari channel Teacher Vivi Lau. Sesiapa yang belum subscribe Teacher Vivi Lau, silalah tekan butang subscribe sebagai tanda sokongan kepada Teacher Vivi Lau. Untuk makluman semua pelajar, nama penuh beliau ialah Teacher Lau Chai Wee dari Pusat Tingkatan 6 SMK Tinggi Kelang. Tajuk yang disampaikan oleh Teacher Lau pada petang ini ialah Electrochemistry Revision, khas untuk pelajar matrikulasi dan STPM. Kelas ini akan berlangsung lebih kurang sejam. Bersama cikgu pada petang ini ialah Cikgu Shannon dari Kolej Matrikulasi Pulau Pinang selaku control host dan juga ketua panitia kimia. Dan juga Cikgu Kong Shilin dari Kolej Matrikulasi Perak sebagai pemerhati. Sebelum kita meneruskan kelas kita, ingin cikgu ingatkan semua pelajar dan penonton yang ingin menghantar komen agar menggunakan bahasa yang sopan dan gambar profil yang bersesuaian untuk tontonan umum. Sila fokus pada isi pelajaran yang akan disampaikan dan hanya menggunakan ruang chat untuk menjawab soalan atau jika ada soalan yang hendak diajukan. Pada akhir siaran ini, link e-sijil akan diberi dan anda hanya mempunyai 30 minit sahaja untuk mengisi maklumat. Pastikan anda menggunakan email e-didik sahaja. Cikgu percaya semua yang hadir pada petang ini merupakan pelajar-pelajar cemerlang dan marilah kita menunjukkan disiplin yang terbaik. Oleh itu, cikgu harap semua memberi sepenuh tempuan semasa kelas ini bersiaran. Tanpa membuang masa lagi, cikgu serahkan kelas kepada Teacher Vivi Lau. Dipersilakan Teacher Vivi Lau.
Hi. Good afternoon, students and teachers. Okay, today I'm going to teach about electrochemistry for the central students and the SPTM and the matriculation students. Okay. So this is the second type of the electrochemistry. Okay, before I begin the lesson, let me introduce myself first. So I'm teaching in Pusat Tingkatan 6 SMK Tinggi Kelang with a teaching experience 19 years, and my YouTube channel is Vivi Lau. Okay, so this is a Pra-U team mathematics teach with teacher in the Ketua Panitia, Teacher Aileen, Teacher Zanaria, and the other teachers. Okay, then we have biology team. We have Cikgu Faiza as a Ketua Panitia. Then we have Cikgu Wawa, Cikgu Naini, and Cikgu Fatia. Okay, next we have physics team. So physics team led by the Ketua Panitia Rosmaya. Okay, next we have accounts and economy teams. So the Ketua Panitia is Madam Fiji. Cikgu Yati is an account teacher. Cikgu Lee and Cikgu East they are the economic teachers. Okay, so last but not least, we have chemistry team. Ketua Panitia is Cikgu Shannon, and we have member Cikgu E, Teacher Tang as the moderator today. Cikgu Shannon as our control host today. Cikgu Mawar Kimia and Teacher Kong as the pemerhati today. Okay, so let's begin the lesson. So the learning outcomes for today's lessons are, the first one is to compare the principles of electrolytic cells to electrochemical cells. So the first part I have explained to you about the electrochemical cells. So today we will focus on electrolytic cells. Okay. Second, you have to learn to predict the products formed during electrolysis. Okay, next you have to state the Faraday's first and second laws of electrolysis. Then number 4, state the relationship between the Faraday constant, the Avogadro constant, and the electric charge. So next you have to calculate the quantity of electricity used, the mass of materials, or the gas volume liberated during electrolysis. So let's see the comparison between the electrolytic cell and the electrochemical cells. So we compare in terms of 3 components. So the first one, energy change. So for electrochemical cells, you learn today. So it's the chemical energy convert to electrical energy. So you can see here. So the reaction of the chemical reaction of the electrolytes and the electrodes will produce electric chemical energy. Then it convert to electrical energies. Okay. And the light bulb is lighting up. Okay. As for the electrolytic cells, so it's a electrical energy convert to the electrochemical energy. So the electrolytic cell is connect to a battery. So the battery is the electrochemical cells. So electrical energy is provided to the electrodes, and the electrochemical energy is produced when the chemical reaction occurs. Okay, so then second comparison is according to the types of reactions. So both have redox reactions occurs. Okay, so both at anode. So anode is where the oxidation occurs, and cathode is where the reduction occurs. Then next we look at the charge of electrodes. So the charge of electrodes are different. So for the electrochemical cells, anode is the negative electrode, while the cathode is the positive electrode. Whereas the electrolytic cell is opposite. So the cathode is the negative electrode, and anode is the positive electrode. Okay. So you can see here the anode is negative because it's the oxidation occur. So electron produced here, so we'll make the electron negative. Okay. Then the electron will be goes to the salt bridge and reach the cathode here. So the ion here will accept the electron and form the metal. So here is a positive electron to attract the electrons. Okay, then here the anode is positive terminal because the anode is connected to the battery that is positive. Okay, and the cathode is negative terminal because the negative cathode electrode here is connected to the negative terminal of the battery. Okay, so we look at the next slide. Okay, so now we look at the components of electrolytic cells. Okay, so electrolytic cell we have electrodes, battery, and electrolyte. So like just now you see the electrode is the circuit connector. So it's a site of precipitation for insoluble products. Okay, so here in this case is a cathode here. You can see the precipitation of the copper solid. Okay, then we have battery. It's a source of direct current that forces electrons move from anode to cathodes. And we have electrolytes, so a compound that conducts electricity in the presence of freely moved anions and cations. Okay. So the electrolyte here is a acidified copper 2 sulfate. And the electrodes we have, the anode here is impure copper, the cathode here is pure copper. So this is for the purification of copper. Then next one we look at the electrolytic cells and its operation. So first we look at the operation. So we have anode and cathodes. So anode is undergo oxidation, like you memorized last time. The anode is an oxide. So it's an electrode where the oxidation occurs. Cathode is reduction. So you memorize as red cat. So means reduction occur here. The positive ions and the negative ion. So anion is the negative ion. Okay, so anode is positive terminals will attract the anions. So anions is negative, that is correct ions. Then the cathode is negative will attract the positive ion. So it's cations. Okay, so the anions attract to the positive terminals, then undergo oxidation. So the anion lost electrons to form atoms. Okay. So the half cell equation you can see here, the negative ions and ions donate electron and form the atoms as atoms. And the reduction here, the k-ions, the positive ion was attracted to the negative terminal opposite charge. So the k-ions accept electrons to form atoms. So the half cell equation, you can see here, the Yn positive, the k-ions accept electron and form the metals, metals. Okay, so this is a basic. I think most of you know this one. So we look at the next slide, factors that affect the types of products formed during electrolysis. So there are three factors that affect the selective discharge of ions in an electrolyte for aqueous solutions. This one for aqueous solution. Okay. So the first factor is the value of the standard reduction, or we say standard electrode potential, or the positions of the ions in the electrochemical series. Then second factor is the concentration of ions in the electrolyte. Then the third factor is the nature of electrodes used, whether it's inert, means unreactive, or reactive or active electrodes. Okay, so this one is for aqueous. So today we will also look at moltens and also electrolysis of water. Okay, so example of aqueous solution, we will look at electrolysis of copper 2 sulfate. Okay, then we have sodium chloride, whether it's dilute solution or concentrated solution. Okay, so first we look at electrolysis of the molten salt. So molten salt is where the ionic compound is melted. Okay, so from the liquid. So we only have two ions here. Sodium chloride, we have sodium ion and the chloride ion here. So the molten salt contains the freely moved ions when it's melted above its melting point. So for the site of reactions, anion will be attracted to the positive terminal anode. Then the cation will be attracted to the negative terminal cathode. Okay. So oxidation occurs at the anode. Chloride ions are oxidized to form the chlorine gas. Then at the cathode, sodium ions are reduced to form the sodium metals. Okay. So the half-cell equation here, chloride ion undergo oxidation, so form the chlorine gas. Okay. So we have to write the physical states for the equation. Okay, then sodium ion attracted to the negative terminal form sodium metal reduction occurs. Okay, so far any question? Okay,
No questions yet. No questions yet from
yeah, thank
students.
you, Teacher Tang. Okay, so let's continue with the next slide. Okay, now we look at electrolysis of water. So water here just contains water molecules. So at the anode, okay, because the electrolysis of water, we have very little water resources. So the electrolysis is water molecules. So water molecules oxidize at the anode to form oxygen gas. Then at the cathode, water molecules are reduced to form hydrogen gas. Okay. So water will form oxygen plus 4 hydrogen ions and 4 electrons. At the cathode, water will accept 2 electrons, form hydrogen gas and hydroxide ions. Okay. Then we look at electrolysis of eco solution. So remember just now we have 3 factors that affect the electrolysis of the eco solution. Okay, so eco solution is a water soluble salt dissolving in water. Okay. So we have positive ion, cation, and negative ions, anions. Okay, so the water molecules in the eco solution will be selected to undergo electrolysis, depends on the conditions. Okay. So if water is selected, so like just now, so oxidation, water will form oxygen, reduction, water will form hydrogen. Okay. So we look at the example. Okay, for the first paper. Okay. So standard electropotential value and the selective of discharge of ions. So species with more positive standard electropotential value will be reduced at the cathode. And species with more negative standard electropotential value will be oxidized at the anode. Okay, example, we use a copper 2 sulfate solution. Okay, so can you tell me what are the ions inside the copper 2 sulfate solution here? For us to decide which one to undergo oxidation or reduction in the electrolysis. Okay, so students, you can write in the chat box the ions inside this eco solution that we have to consider for the electrolysis. So any answer from the
No,
students?
no response yet. No response yet.
Okay, students, you try. So you look at the formula here. So you write out the possible ions that we can decide whether can undergo oxidation or reduction here.
Maybe teacher Vivi, you can guide them, give them more hints, more hints.
Okay, so we see here. Okay, so copper sulfate and is an eco solution. So what is the positive ion here, students? That you learn in form 4. Okay, which one is a positive ion? Which one is a negative ion? Cu is metal, right? So should be positive or negative. Then So is non-metals. So Aq here means we have water here. Okay, so I give you one on. So beside ions we have water here. Okay, here. So water undergo electrolysis. So beside water we have also hydrogen ions. Okay, and very little of hydrogen ion. Okay, so from the formula, what is the positive ion and negative ion? Students, try to write your answer. Remember, normally metal is positive ion. So the non-metals negative ions. No answer yet, teacher.
No response yet from Vivi.
Okay.
Yeah.
So we continue. So you can. So copper is metal, and so we have copper 2 ions and SO4 2 negative ion. SO4 2 negative. Okay. So we have this 5 species to consider. This one undergo reaction. Okay. So which one is the will go to cathode and which one will go to anode? Okay, students. Which ion here or okay, we have water. So which one will go to attracted to cathode? Which one will attracted to anode? Okay, so so you can just write in the chat box. Cathode we have what ions? Anode we have what ions? So remember the cathode is negative terminal. Okay, anode is a positive terminal. So the opposite charge one will attract, okay, attraction. So positive ion will go to the negative terminal cathode, so that they call ions. So this one will go to cathode, hydrogen ion. This one. Water also can. Okay. Then anode we have positive terminal, so the negative ion will go to the anodes. Okay. Okay, so now we look at the next slide. Okay, so for this one, is inert electron. We use inert electron because inert electron is unreactive, so it will not react. So if you use reactive electrodes, so you have to consider the third factors. Electron will affect the selective of discharge of ions. Okay, so we look at the okay, so we can see here the okay at the cathode. Okay, so we have copper, water. So we compare these two. Okay, so the more positive one will undergo reduction. The more positive one. So copper ion is selected instead of water. Okay. We also have hydrogen ion, but hydrogen ion is too little. So for physics, we'll just consider water and copper. So we don't consider hydrogen ion from the electrolysis of water. Okay. So you have to consider water and copper only. Okay. So copper to ion is reduced rather than water because standard electrode potential of copper is more positive. Okay, next we look at the anode. Okay, so the equation is copper to ion plus 2 electron from copper at the cathode for the electrolysis of copper to sulfate. Copper to sulfate. Okay, so when we look at the anode, so the negative ion attracted to the anode, sulfate and water. So hydroxide ion is not considered because too little hydroxide. Okay, so we have to choose the less positive or more negative one. So in this case, both positive. So you look at the less positive one. So water is oxidized compared to sulfate. Okay, because the electrode potential of water is more negative. Okay. So the equation is at the anode we have 2 mole of water undergo oxidation from 1 mole of oxygen and 4 mole of hydrogen ion. So 4 electron is donated. Okay. Okay, then we look at second factor. Second factor is concentration and selective of discharge of ions, concentration of the electrolytes. So the species with higher concentration is preferentially discharged. Is preferred to discharge. Okay. So example, we have electrolysis of 2.0 mole per dm³ of sodium nitrate. Okay, so so this factor is not applied if the difference is very big. Difference of the electrode potential is very big. So we look at the reaction. Okay, so sodium nitrate, we have sodium ion and nitrate ion and the water. Okay, so we don't need to consider hydrogen ion and hydroxide ion. Okay, okay, so at the so we compare sodium and water. Okay. So sodium ion is not selected for discharge, even though the concentration of sodium ion is higher, but because of the electrode potential difference is too big. This one is too negative to undergo reduction. Okay. So but for concentrated halide ions, like chloride ions, bromide ion, and iodide ions, if you use these three, so halide ion will be selected for the discharge to produce halogens instead of water. So example is the sodium chloride, concentrated 2.0 molar sodium chloride. You use a chloride ion. Okay, then we look at the third factor. Third factor, the nature of electrodes and selective of discharge of ions. Okay, so we have inert electrodes and
Teacher Vivi,
reactive electrodes.
Teacher Vivi,
Yes.
shall we stop for a break?
Okay. Yeah.
Tuition online percuma. Tuition online percuma. Layari www.academyyoutuber bagi mengikuti tuition online secara percuma. Prasekolah, sekolah rendah, sekolah menengah, semua ada di Akademi YouTuber. Rujuk jadual di laman sesawang www.academyyoutuber.com. Semoga masa terluang anak-anak anda diisi dengan sebaiknya. Tuition online percuma mestilah Akademi YouTuber.
Teacher Vivi, you may continue your lesson.
Okay, thank you, teacher Tan. Okay, so the third factors are nature of electrodes and the selective of discharge of ions. So if we use inert electrode, the electrode will not participate in the redox reactions. Example of inert electrode is graphite and platinum. Okay. Then if we use reactive electrode or active electrode, the electrode will maybe undergo redox reaction. It depends on the condition used. So example of the reactive electrode, we have copper electrode in the electrolysis of the copper 2 sulfate. Okay, so we look at first example. So this one is a copper 2 sulfate. Okay, that's all. So the copper will undergo oxidation and form the copper 2 ion. Then at the cathode, the copper 2 ion will undergo reduction and form the copper solid and deposited on the cathode. Okay, so another example here is silver electrolysis of silver nitrate. Okay, using the silver as a anode. Okay, so the silver will undergo oxidation to form silver ion instead of water, and the anode will dissolve. Second example, we have the electrolysis of the brine. Brine is seawater. Okay, saturated sodium chloride. So means this one the chloride ion will undergo oxidations. Then the cathode is mercury. Okay, so the sodium ion is selected for discharge, and as sodium produced from the sodium amalgam. Okay, you write as this one sodium slash mercury, and mercury is Hg and Hydrogen. Okay, sodium amalgam. Even though the electron potential value is very negative for sodium, normally we don't use it, but for this case is concentrated. So we use sodium here. Okay, then another side is a chlorine form. Chloride ions undergo oxidation from the chlorine gas. Okay, so now we have question number 1. Okay. So we have two electrolytic cells connected in series. So we have WX are the aluminum electrodes. Then we have Y and Z is graphite or carbon electrodes. So the electrolyte for the first cell is aluminum chloride, 1.0 mole per dm. Then we have sulfuric acid, 0.1 mole per dm. Okay. So the questions. Okay. please write the ionic equation. Write the ionic equation for the electrode W, X, Y, and Z. Okay. So you try to, so students try to do now. You can write your answer in the chat box. So W we have aluminum, then X also aluminum. Y and Z is graphite carbon electrodes. Then the electrolyte is AlCl3. This one is H2SO4 sulfate.
Teacher Vivi, maybe you can give them.
Okay. So working time. Okay. So we look at here. Okay. So here we have AlCl3 as an electrolyte. So what are the ions inside here? What are the ions we have here? So we have Al3 plus and Cl negative, and also water. Okay, so the electron potential. Okay, what was it? I show you the. So when you have reactive, aluminum is a reactive electrode. So the reactive electrode will react. So aluminum is from what ion? So what do you think you have here? The W? Okay, okay. So
Teacher Vivi, one student Amil say aluminium anode dissolve to form aluminium ion, aluminium 3 plus ion.
so first one, so correct. So for the
Yeah.
W, we have aluminum resolve and form the aluminum 3 plus. Okay, very good. Okay, so the second one, the X electrode over here. So here we have what ions attract to the negative terminal. So negative terminal must be the positive ion attract here. Okay, so which ion will be attracted to the negative terminal here? So we have
No response yet. Maybe they are still thinking.
okay. So
Maybe you can give them hints, Teacher Vivi. Yeah.
okay. So we have Cl negative here. Okay. Besides Cl negative here, what else you have? Water, right? So what do you think we have here? Here is the negative electron. So what positive ion attract to the negative electron? We have aluminum ion, positive ion. So which one will attracted here? Cl negative or Al3 positive here? Which one positive ion or negative ion attracted to the negative terminals of the opposite charge, right? So Al3 plus or Cl negative attracted to the negative terminal. Okay, we look at the second one. Second one, we have sulfuric acid. So what are the ions we have here? We have hydrogen ions, sulfate ion, and we have water dilute solutions. Okay, because this one is inert electrolyte, it will not react. So there's the ions in the electrolyte reacts in the water. So any answer from the student?
I think the Abdul Kuyum is answering for X. He said aluminium ion.
Okay, very good.
Aluminium ion.
Aluminium ion, right? So what happened to the aluminium ion? At the negative terminal, which is a cathode here. So at the cathode is undergo reduction rate, red cat, you memorize that, red cat. So the aluminium ion undergo reduction by donating electron or accepting electron. Should be donate electron or accept electron reduction. So aluminium ion will form the aluminium metal, so accept electron. Okay. Okay, then we look at the Y and Z. So Y we have, just now I told you the hydrogen ion, sulfate ion, and water. So the electron will not react. Okay. So positive terminal, which ion will be attracted to the positive terminals? Hydrogen ion, sulfate ion, or water? So it's positive, so will attract the opposite charge. So here should be okay. So like just now the example, previous example. So we see this one. If you're not sure the potential value, sulfate. Okay. So sulfate is positive 2.01. Water is 1.23 watt. Okay. So which one will go to the negative and the positive terminal? So negative ion go to the positive terminal opposite charge. So must be the more negative one. More negative one. So the water.
Teacher Vivi Lau, Muhammad Amil, he give the answer. He said water will be oxidized at Y to form oxygen gas.
Okay, very good. So you write this one. So water oxidize to form the oxygen gas. Okay, very good. So your answer is correct. So water, water and sulfate will go here, but it's water is selected to undergo oxidation. Okay, correct. Your answer. So oxygen form, very good. Okay, so the last one, Z. So Z is a negative terminal. So we have used the water and sulfate. Okay, so now we have hydrogen ion and water. So which one will react with will go to the negative terminals? So we have hydrogen ion here. So here, Z, hydrogen ion or water?
Teacher Vivi, maybe you can let them see the SRP value again.
Again. So for the hydrogen ion here didn't show, but you can see here. Here the water to form hydrogen gas is negative 0.83. So the SHE, the standard hydrogen electron, is, you know, last time it's 0 watt for the hydrogen ion one. So for hydrogen ion is 0. Right here, so you can see. So hydrogen one is 0. So which one is more positive? So hydrogen ion is more positive compared to this one negative. So hydrogen ion is selected to discharge. So you will get hydrogen ions. Okay. So the answer here is hydrogen ion undergo reduction instead of the water. Okay. Any answer from the student?
Not yet. Not yet.
Okay. So these are the
Yeah.
answers. So remember, if you have reactive electrode, the electrode will undergo reactions for the positive terminal, will undergo reaction. Then the ions in the electrolyte will react to form the metal. Okay, form the metal at the and deposited on the electrode, the reactive electrode. Okay. Then for the eco solutions, so you have to see. So when it's okay, and not a positive terminal will attract the negative ion. Okay, then you have to choose the one most negative one to undergo the oxidations. Okay, so water here instead of the sulfate ion. Okay, then in the negative terminal cathode, okay, positive ion will attract to the cathode, negative terminal opposite charge. So you have to choose a more positive one, okay, to undergo reduction. So here is the hydrogen ions. Okay. Okay. Any question from the students?
So far, no questions from the students yet.
Okay, so we look at the we have 10 minutes. Okay, we look at so now I go fast. Let's force law. So we have let's force law states that the amount, okay, mass of substance produced, this one is mass, or dissolved at electrode is directly proportional to the quantity of electricity that passes through the electrolytes. Okay, so the mass proportional to the Q1 quantity of electricity. Okay, so we have Q equal to IT. So Q is the quantity of electricity in column, big capital C. Then I is the current in amperes, A. T is the time in seconds. Then we have Faraday's second law. Says that the amount of different substances produced by the same amount of electricity is inversely proportional to the charge, small q, of the ions. Okay, so M inversely proportional to the U. Okay, so the relationship between Faraday constants F, Avogadro constants L, and the electronic charge is F equal to L times E. Then steps in solving problems on Faraday's law of electrolysis. So we have to write the half cell equation and cathode or anode first. Okay. After you write the equation, you calculate the quantity of electric charge Q equal to IT. Then based on the half cell equation, you make the stoichiometric comparisons. So means from the equation just now, you mention more of electrons and the more of product form. Okay. Then finally, you can calculate the amount of product form. Okay, so if you want to calculate amount of product form, you go from step 1 to step 4. So if sometimes your question asks you to find the time taken, then you have to do reversely. Okay. Okay, so we use the example just now. This example. Okay, so if a steady current of 5.0 ampere was passed through for 75.0 minutes, calculate the mass of product formed at electrode S. Okay, so you are given Faraday equal to 96500 coulomb per mole. Then the relative atomic mass of aluminum is 27.0. Okay. So the answer here. So first step, you write the equation. So they ask about the electrode X. So electrode X is a cathode. So cathode just now aluminum ion. Aluminum ion reduction by acid 3 electron from the aluminum. Then second step, you calculate the quantity of electricity, Q equal to IT. So 5.0 ampere times 75.0 minutes. So we have to convert to second. So you multiply by 60. So you get 22500 coulomb. Okay, so based on the equation, half equation, you write the stoichiometric relationship. So 1 mole of aluminum required 3 mole of electrons to form. So this one 3 lines is equivalent. You also can write in sentence. So 1 mole of aluminum required 3 mole of electrons means we need 3 times 96500 coulomb of electricity. Okay. So the question asks for mass of product. Okay, so you have to find more first. Always find the number of mole of substance form first. So take the coulomb electricity provided 22500 divided by 3 times 96500. So this is the electricity required to form 1 mole. So these are the electricity provided. So you take 22500 divided by 3 times 96500. So you will get 0.0777 mole of aluminum form. So mass of aluminum equal to mole times molar mass or relative atomic mass. So equal to 2.098. So based on the question, the smallest significant figures is 2. So your final answer is 2.1 gram. Okay. for 2.1 gram. Any question from the students?
So far, no question yet from the students.
Okay, no question. Okay. So we see. Okay, so the concentration will not change at the end because it's a standard condition. Okay, so the last question. Okay, so chlorine can be obtained from the electrolysis of brine. What volume of chlorine gas will be collected at anode when a current of 250 ampere is allowed to fall for 40.0 minutes? So this one anodes, so because it's concentrated, and so chloride ion will undergo oxidation. Okay, so you try to write the equation yourself. Okay, so I show you the chloride ion undergo oxidation. Okay, so you write the half equation first. Enough time for you to do. 4 minutes. Okay, you try to do one. So step 1, write the half equation. Then you calculate the quantity of electricity provided like just now. Q equal to IT. Q equal to IT. Okay, after you calculate the quantity of electricity, you find the you find the relationship based on the half equation. Okay, then you calculate the mole of the mole of chlorine form. Okay, so they want volume, so you must multiply by the molar volume. Okay. So this four step, balance the half equation. Okay. Then Q equal to IT to calculate the quantity of electricity. Then based on the half equation, you will find the relationship. Okay. So calculate the moles of chlorine form. Okay. And the volume, finally the volume of chlorine. Any answer from the students?
No answer yet.
So you are provided with the okay. So the I is 250 ampere. Then you are given minutes also, so you have to convert to seconds. Okay. After that, okay, you are given 1 Faraday is 96500. Okay. So molar volume. So the question didn't mention condition is spin condition. Okay, so 24.0. Any answer?
No answer yet.
Okay, so I think left how many minutes? How much time left?
5 seconds. 5 seconds left.
Okay, so I show the answer straight. Okay. So I show you the answer straight. Okay. So the half equation, you balance and 2 chloride ion form 1 more chlorine plus 2 electrons. The Q quantity of electricity Q equal to IT 250 times 40.0 times 60. So you get this one. So more of electron is you take the quantity of electricity provided. Okay, so 1 more electron required this 96500. Okay, so equal to 6.22 more. Okay, so more of chlorine is 6.22 divided by 2. Okay, So equal to 3.11 more. Okay, if you don't want to write more of electron, you want to write more of Pauling straight also can. So means you can cancel this one. You write more of Paulins is 600,000 divided by 2 times 96500 also can. You will get 3.11 more. Okay. So volume of Pauling is the mole multiplied by molar volume. So you get 74.6 dm3. Okay. If the question required cm3, then you divided by 1000. Okay. So you get the cm3. Okay. Any question?
No question from the students.
Okay, so I have because of the time constraint, I still have other questions, so I will share in the YouTube. Okay, later. Okay. Thank you, class.
Okey. Terima kasih diucapkan kepada Teacher Vivi Lau atas perkongsian ilmu yang sangat menarik, mudah difahami dan sangat menarik. Selesailah kelas kita pada petang ini. Tadi ucapkan kepada semua yang setia mengikuti kelas pada petang ini dari awal sehingga ke saat akhir. Sebelum kita tamatkan sesi siaran langsung hari ini, mohon tutup ruangan chat dan klik button subscribe yang masih merah dan aktifkan ikon loceng supaya kamu tidak terlepas sesi kelas yang seterusnya. Sekiranya anda suka apa yang dipelajari pada hari ini, anda boleh like and share kepada rakan-rakan di social media anda. Kelas seterusnya untuk tuition kimia adalah pada hari dan waktu yang sama pada minggu hadapan. Hari Ahad pukul 3.30 petang. Jangan lupa juga untuk dapatkan jadual tuition online terkini melalui portal www.academyyoutuber.com serta dapatkan info terkini. Bantu cikgu untuk sebarkan kelas tuition percuma ini kepada rakan-rakan dan guru-guru di seluruh Malaysia. Semoga kita dapat manfaat daripada kelas-kelas yang dijalankan. Ingat hashtag bermula percuma selamanya percuma. Terima kasih kepada semua. Kelas tuition online percuma berakhir sudah. Di lain siaran kita berjumpa lagi. Bye.
Berikutan pengumuman penutupan sekolah sehingga akhir persekolahan. Pengajaran dan pembelajaran secara home-based learning tetap diteruskan. Oleh itu, kami di Akademi YouTuber menyediakan tuition online percuma pertama di Malaysia dari prasekolah hinggalah ke sekolah menengah dengan kerjasama E-Didik Malaysia dan Kelab Guru Malaysia. Kenapa bayar jika anda boleh dapat percuma? Bermula percuma, selamanya akan percuma. Manfaatkan peluang yang ada. Jangan tunggu lagi, sertailah sekarang. Untuk maklumat lanjut, layari www.academyyoutuber.com.
Dibawakan kepada anda oleh Akademi YouTuber.